Imagine you're typing a message on your phone. You tap a key, and instantly you see the letter appear on screen. You make a typo, and a red squiggly line appears underneath. This immediate response from your device is called feedback. In human computer interaction, or HCI, feedback is the information a system provides to users about its current state, the results of their actions, or guidance for future interactions. Think of feedback as a communication bridge between human intentions and computer responses. When you click a button, the system needs to tell you something happened. When you make an error, it needs to guide you toward the correct action. Let's look at some real-world examples. Here we can see how good feedback design makes interfaces more intuitive and user-friendly, while poor feedback design leads to confusion and frustration. Modern interfaces use sophisticated feedback systems to create seamless user experiences. From visual indicators to haptic responses, feedback helps users understand what's happening and what they should do next. Effective feedback is crucial for creating smooth, intuitive user experiences. It reduces confusion, prevents errors, and builds trust between users and technology. Without proper feedback, even the most powerful systems can feel frustrating and unreliable. Everywhere in our daily digital interactions, yet we often don't even notice it. Let's explore 3 common examples that happen dozens of times each day. Picture this. You're rushing to catch an elevator. You press the button for your floor, and immediately it lights up with a soft glow. This simple illumination is feedback. The system is telling you, I received your request and I'm processing it. Now imagine typing an important email. Each time you press a key, you hear a subtle click and see the letter appear on screen. Without this immediate feedback, typing would feel disconnected and uncertain. The sound and visual confirmation tell you your input was registered successfully. Finally, consider uploading a large file to the cloud. Instead of wondering if anything is happening, you see a progress bar slowly filling up, showing you exactly how much has been completed. This feedback transforms an anxious wait into an informed experience. These 3 examples, the glowing elevator button, the clicking keyboard, and the filling progress bar, all serve the same fundamental purpose. They confirm that our actions have been received and processed, keeping us informed about what's happening behind the scenes. Picture this scenario. You're trying to submit an important online form. You click the submit button, but nothing happens. No confirmation, no loading indicator, no response at all. Without feedback, you're left in a state of uncertainty. Did the system receive your input? Is it processing? Has something gone wrong? This uncertainty leads to frustration and often causes users to click multiple times, potentially creating errors. Now let's see how proper feedback transforms this experience. Here's an example of effective button feedback design that immediately confirms user actions. Loading indicators are another crucial form of feedback. They tell users that the system is working and provide an estimate of how long they need to wait. Confirmation feedback is equally important. When users complete an action, they need to know it was successful. This form submission example shows how a clear success message eliminates doubt and builds confidence. Effective feedback is the bridge between human intention and computer understanding. It transforms uncertainty into confidence, confusion into clarity, and frustration into satisfaction. Without it, even the most powerful systems become unusable. Imagine you're using your smartphone to send an important message. You tap the send button, but nothing happens visually. No highlight, no animation, no confirmation. How would you know if your action registered? This is where visual feedback becomes crucial. Visual feedback is our eyes' way of understanding what's happening in digital interfaces. It includes 3 main types: state indicators that show current conditions, status communication through colors, and spatial feedback that responds to our interactions. State indicators are everywhere in digital interfaces. Think about a loading spinner when a web page is loading, or how a button highlights when you hover over it. These visual cues tell us exactly what the system is doing at any moment. Status communication uses colors to instantly convey meaning. Red universally signals errors or danger. Green indicates success or safety, and yellow warns of caution. This color language is so ingrained that we understand it without thinking. Spatial feedback creates interactive experiences that feel natural and responsive. When you hover over a button and it slightly grows or changes color, when images zoom in on mouse over, or when cards lift with shadow effects, these subtle animations make interfaces feel alive and responsive to your presence. Visual feedback is the foundation of intuitive user interfaces. Whether it's a simple button press confirmation, a color-coded status system, or an elegant hover animation, these visual cues guide us through digital experiences seamlessly. They transform cold, unresponsive screens into warm, communicative partners in our daily digital interactions. Imagine you're typing on your smartphone. Every tap produces a subtle click sound that confirms your touch registered. This is auditory feedback, one of the most immediate and intuitive ways computers communicate with us through sound. Auditory feedback serves three primary purposes in human-computer interaction. First, confirmation sounds let us know our actions were registered successfully. Second, alert systems use distinct sounds to communicate different types of system states. Error beeps warn us of problems, while success tones celebrate completed actions. Third, ambient audio provides continuous background information about system activity, like the gentle hum of a computer fan or the subtle sounds that indicate data is being processed. Consider how these sounds shape your daily digital interactions. The satisfying click when you send an email, the distinctive chime of a text message, or the gentle beep when your microwave finishes cooking. Each sound is carefully designed to convey specific information instantly. Effective auditory feedback is immediate, distinctive, and emotionally appropriate. A gentle chime feels welcoming, while a sharp beep demands attention. These sounds become part of our digital language, helping us navigate technology more intuitively and confidently. Imagine you're typing on your smartphone. As your fingers tap the screen, you feel a subtle vibration with each keystroke. This isn't just a random feature, it's haptic feedback, and it's revolutionizing how we interact with digital devices. Haptic feedback is the technology that lets digital devices communicate through touch. It transforms invisible digital actions into physical sensations we can feel, creating a bridge between the virtual and physical worlds. The first type of haptic feedback is vibrations and force feedback. Gaming controllers have used this for decades. When your character gets hit in a video game, the controller shakes, making you feel the impact. The second type is texture simulation on touchscreens. Advanced tablets can now make smooth glass surfaces feel rough, bumpy, or silky. You can actually feel different textures just by sliding your finger across the screen. The third and most advanced type is spatial haptics in virtual and augmented reality. Special gloves and controllers can make you feel like you're actually touching virtual objects. You can feel their weight, texture, and resistance. Advanced haptic systems can even provide force feedback for precise tasks. Robotic arms with haptic feedback allow surgeons to perform delicate operations remotely, feeling exactly what the robot feels. Haptic feedback transforms cold digital interactions into warm human experiences. By engaging our sense of touch, it makes technology feel more natural and intuitive, bridging the gap between what we see on screen and what we feel in our hands. Imagine you're playing a game and you hear that satisfying ding when you complete a level, or you see your fitness app celebrate when you hit your daily step goal. These moments create something powerful called positive feedback loops. A positive feedback loop is a cycle where user actions are rewarded, creating motivation to repeat those actions. Unlike negative feedback that corrects errors, positive feedback reinforces desired behaviors and keeps users engaged. Let's see this in action with Duolingo, the language learning app. Every day you practice, you build a streak. Miss a day, and your streak resets to 0. This simple mechanic has kept millions of users coming back daily. Fitness apps take this further with achievement badges and celebrations. When you hit 20,000 steps, you don't just see a number, you get a colorful badge, maybe some confetti, and the satisfaction of earning something special. Social media platforms have mastered positive feedback loops. Every like, comment, and share triggers a small dopamine release. Instagram even shows you who viewed your stories, turning passive consumption into active engagement tracking. Gaming takes positive feedback to the extreme. Xbox achievements, PlayStation trophies, and Steam badges create entire ecosystems of rewards. Some achievements are so rare that only a small percentage of players ever unlock them, making them incredibly valuable. The psychology behind positive feedback loops is simple but powerful. When we receive a reward, our brain releases dopamine, creating a feeling of satisfaction. This makes us want to repeat the action that led to the reward, creating an endless cycle of engagement. Positive feedback loops are everywhere in modern interfaces because they work. They transform routine tasks into engaging experiences, turning users into active participants who want to return again and again. Understanding these loops helps us design better, more engaging digital experiences. Imagine you're typing an email and accidentally misspell a word. Suddenly, a red squiggly line appears underneath it. This is a negative feedback loop in action. The system detected an error and is helping you correct it. Negative feedback loops are essential mechanisms in human-computer interaction that help maintain system stability by detecting problems and automatically correcting them. Unlike positive feedback that amplifies behavior, negative feedback works to reduce errors and keep systems running smoothly. Let's look at a real-world example that we encounter daily: form validation on websites. When you fill out an online form and make a mistake, the system immediately detects the error and shows you exactly what needs to be fixed. Another common example is spell check functionality. As you type, the system continuously monitors your text and flags potential spelling errors. This immediate feedback allows you to catch and correct mistakes before they become a problem. Negative feedback loops also regulate system behavior automatically. A perfect example is auto brightness on your smartphone. The system continuously monitors ambient light levels and adjusts screen brightness accordingly, maintaining optimal viewing conditions without your intervention. These negative feedback loops work tirelessly behind the scenes to create smoother, more reliable user experiences. They catch our mistakes, guide us toward correct actions, and automatically maintain optimal system performance. Understanding these mechanisms helps us appreciate the sophisticated intelligence built into everyday technology. When you click a button on your phone, how long do you expect to wait before something happens? The answer reveals one of the most critical aspects of user interface design: timing. In human-computer interaction, feedback timing falls into two main categories: immediate feedback for simple actions and progressive feedback for longer processes. Understanding when to use each type can make the difference between a frustrating and delightful user experience. Immediate feedback should happen in under 100 milliseconds. This is the golden standard for simple interactions like button presses, hover effects, or menu selections. At this speed, the response feels instantaneous to users. But what happens when a task takes longer? File uploads, data processing, or complex calculations can't be completed instantly. This is where progressive feedback becomes essential. Progressive feedback keeps users informed during longer processes. Instead of leaving them wondering if anything is happening, we show progress bars, loading animations, or step-by-step indicators. Consider downloading a large file. Without feedback, users might think the system has frozen. But with a progress bar showing percentage completion and estimated time remaining, they understand the process is working and can plan accordingly. The key is matching feedback timing to user expectations. Quick actions need instant confirmation, while longer processes need ongoing communication. This prevents the dreaded "is it working" moment that leads to frustrated users clicking multiple times. Modern applications excel when they respect these timing principles. A well-designed interface provides immediate acknowledgement for every user action, then uses progressive indicators to maintain engagement during longer operations. This creates a sense of responsiveness and control that keeps users confident in the system. Remember, timing isn't just about speed, it's about communication. Every delay is an opportunity to inform users about what's happening, building trust and reducing anxiety in the digital experience. Imagine you're trying to complete an important online form, but every error message you encounter is filled with technical codes and confusing language. This frustrating experience highlights why clarity is absolutely essential in feedback design. Clear feedback design follows three fundamental principles. First, use plain language instead of technical jargon. Second, create visual hierarchy to guide attention. And third, provide contextual help when users need it most. Let's start with plain language. Instead of showing cryptic error codes, effective feedback uses simple, human friendly words that clearly explain what happened and what the user should do next. Visual hierarchy is the second key principle. By using different text sizes, colors, and spacing, we can guide users' attention to the most important information first, making feedback easier to scan and understand. The third principle is contextual help. Instead of leaving users to figure things out alone, effective systems provide guidance exactly when and where it's needed, like interactive walkthroughs and helpful tooltips. Let's see these principles in action. Here's a real-world example showing how clear communication transforms user experience. Notice how the improved version uses simple language, clear visual hierarchy, and provides helpful context. Remember, clarity in feedback design isn't just about being simple, it's about being appropriately simple. Use language your users understand, organize information with clear visual hierarchy, and provide help exactly when it's needed. These principles transform confusing interactions into smooth, confident user experiences. Imagine you're using your smartphone throughout the day. When you tap to open an app, you get a subtle visual highlight. But when you're about to delete all your photos, the system shows a bold warning dialog. This is proportionality in action. Proportionality means matching the intensity of feedback to the importance of the action. Routine actions get gentle confirmations, while critical actions demand your full attention. Consider typing in a text field. Each keystroke provides minimal visual feedback, perhaps a cursor blink or character appearance. This subtle response is perfect because typing is a frequent, low-risk action. Now imagine you're about to delete an important file. The system should grab your attention with a prominent dialog box, clear warning text, and distinct action buttons. The high stakes demand high-intensity feedback. Different types of messages require different levels of visual intensity. Success messages can be gentle in green, warnings need moderate attention in yellow, while errors demand immediate notice with bold red styling. When proportionality goes wrong, users become frustrated. Imagine if every button click triggered a loud sound and bright flash, you'd quickly become overwhelmed. Or if deleting files had no confirmation at all, disasters would happen daily. Good proportional design creates a natural hierarchy. Users learn to expect gentle feedback for routine tasks and pay attention when the system uses stronger visual cues. This builds trust and reduces cognitive load, making interfaces feel intuitive and reliable. Meet Sarah, a software developer who lost her vision 5 years ago. Every morning, she opens her laptop and navigates complex code using only sound and touch. Her success depends entirely on how well technology provides feedback through multiple senses. Accessible feedback design means creating systems that communicate through multiple sensory channels. When one sense isn't available, others step in to provide the same essential information. Consider a simple button click. For most users, the visual highlight is enough. But accessible design provides a click sound for those who can't see the change, and a subtle vibration for those who can't hear the sound. Real accessibility systems look like this. Here we see how assistive technology connects different input and output methods to create a complete accessible experience. Customization is crucial for accessibility. Users need control over how feedback is delivered. Some prefer high-contrast visuals, others need larger text, and many want to adjust sound levels or disable certain types of feedback entirely. Modern operating systems provide extensive accessibility settings. Here's Windows showing how users can customize their display and feedback preferences to match their specific needs. Screen reader compatibility is essential for users who are blind or have low vision. This means providing proper text labels for all interactive elements, logical reading order, and meaningful descriptions for images and buttons. The beautiful truth about accessible design is that it benefits everyone. Captions help in noisy environments, voice commands are useful when your hands are full, and clear visual feedback makes interfaces easier for all users to understand. Imagine walking into a building where every door handle works differently. Some you push, some you pull, some you slide. This chaos is exactly what happens when digital interfaces lack consistency. Consistency in user interface feedback means that similar actions always produce similar responses. When users click a button, they expect the same visual, auditory, or haptic feedback every time. Design systems are the foundation of consistent feedback. They establish standardized patterns for colors, typography, animations, and interactions that teams follow across an entire product. Consider navigation menus. A well-designed system ensures that hovering over any menu item produces the same visual feedback, perhaps a subtle color change or underline animation. Predictable behavior builds user confidence. When users learn that red always means error and green always means success, they can navigate your interface intuitively without having to relearn patterns. Inconsistent feedback creates cognitive load. Users waste mental energy trying to understand different patterns instead of focusing on their actual tasks. This leads to frustration and errors. The solution is establishing clear standards. Document your feedback patterns, create reusable components, and ensure every team member understands when and how to use each type of feedback. Remember, consistency isn't about making everything identical. It's about creating predictable patterns that users can rely on. When feedback is consistent, users can focus on their goals instead of figuring out how your interface works. Imagine you're trying to submit an important form online. You click Submit, and suddenly this appears on your screen. Something went wrong. That's it. No explanation, no guidance, just frustration. This is what bad error message design looks like. Research shows that 73% of users abandon their tasks when they encounter unclear error messages like this. But why do these messages fail so badly? Let's examine what makes error messages ineffective. Here are words and phrases that should never appear in error messages because they provide no useful information to users. Words like invalid, illegal, bad, and fatal create anxiety without providing solutions. Phrases like something went wrong or an error occurred state the obvious without explaining what happened or how to fix it. Now, let's see the difference between bad and good error message design. Here's a perfect example of how the same login error can be communicated in two completely different ways. The good message clearly states that the username or password doesn't match, giving users specific information about what went wrong. The bad message simply says the user cannot log in, providing no actionable information. Here's an excellent example of effective error message design. This Windows hard disk warning provides specific information about the problem, explains the consequences, and offers clear next steps. Notice how this message follows the 3 pillars of good error design. It's specific about the hard disk problem, it's actionable with backup options, and it provides recovery guidance to prevent data loss. Let's see the dramatic difference in user experience. When users encounter clear, helpful error messages, they can quickly understand and resolve issues, leading to successful task completion. The impact is measurable. Clear error messages reduce user errors by 65% in form completion tasks and increase overall user satisfaction significantly. Good error design isn't just about being helpful, it's about respecting users' time and intelligence. Meet Sarah. Every morning, she wakes up to this, a phone bombarded with dozens of notifications from apps competing for her attention. Research shows the average smartphone user receives over 80 notifications daily. This overwhelming flood leads to notification blindness, where users simply ignore or disable notifications entirely. In fact, 67% of users have disabled notifications completely. But there's a better way. Let's see how intelligent notification design can transform this experience. Here's Gmail's approach to notification management. Instead of sending separate alerts for each email, Gmail intelligently groups related messages and provides summary notifications. Now Sarah's phone shows only 3 grouped notifications instead of dozens. High-priority items like urgent emails are prominently displayed, while less important social updates are quietly summarized. This intelligent approach uses priority-based delivery systems. Messages are categorized by importance and grouped by context, reducing cognitive load while ensuring critical information reaches users. Effective notification systems follow 4 key principles: group related notifications together, prioritize by importance, respect user attention by avoiding unnecessary interruptions, and allow users to customize their preferences. User customization is crucial. Just as users can choose visual themes for their workspace, they should be able to control when, how, and which notifications they receive. The results speak for themselves. Well-designed notification systems show a 40% increase in user engagement, 65% reduction in notification fatigue, and 78% improvement in task completion rates. Smart notification design doesn't just reduce annoyance, it actively helps users accomplish their goals. When Apple introduced the Taptic Engine in 2015, they didn't just add vibration to their devices, they revolutionized how we feel technology. This isn't your typical phone buzzer. It's a precision engineered system that speaks to your sense of touch in ways that feel almost magical. To understand what makes the Taptic Engine special, let's look inside an iPhone. Unlike traditional vibration motors that simply spin weights, Apple's Taptic Engine uses a linear actuator, a sophisticated electromagnetic system that can create precise, controlled vibrations. The magic happens in how iOS uses this hardware. Every interaction has its own unique haptic signature. When you type on the keyboard, you feel a gentle tap. When you receive a notification, there's a distinct double tap pattern. When you use 3D touch, the feedback varies based on pressure. What makes Apple's approach brilliant is the contextual intelligence. The system doesn't just vibrate, it communicates. A successful Face ID unlock feels different from a failed attempt. Scrolling to the end of a list has its own unique bounce feedback. Each haptic response tells you exactly what just happened without you even looking at the screen. The results speak for themselves. In accessibility studies, Apple's haptic feedback achieved an impressive 89% user satisfaction rating. Users reported that the subtle, varied responses made their devices feel more responsive and intuitive. The feedback was described as natural and unobtrusive, present when needed, but never overwhelming. Apple's Taptic Engine demonstrates a fundamental principle of great feedback design. It's not about the technology itself, but how thoughtfully it's implemented. By creating contextual, subtle, and meaningful haptic responses, Apple transformed a simple vibration motor into a sophisticated communication channel between human and machine. Meet Sarah, a busy professional who decided to learn Spanish. Like millions of users worldwide, she downloaded Duolingo and discovered something remarkable. Learning a language had never felt so engaging. Duolingo's secret weapon isn't just great content. It's their masterful use of gamified feedback systems that keep users coming back day after day. The first feedback mechanism Sarah encounters is the streak counter. This simple number with a fire icon tracks consecutive days of learning, creating a powerful psychological commitment. As Sarah continues learning, the streak grows. Day 15, day 30, day 100. Each number becomes a badge of honor, making the thought of breaking the streak almost unbearable. But streaks are just the beginning. Duolingo showers users with achievement badges for every milestone, completing lessons, perfect weeks, reaching new levels. Each badge tells a story of progress and creates what psychologists call intermittent reinforcement, the most powerful form of behavioral conditioning. When Sarah completes a lesson, Duolingo doesn't just move on quietly. Instead, it celebrates with vibrant animations, confetti, and encouraging messages. But Duolingo's feedback isn't just about celebration. When Sarah makes a mistake, the app provides immediate correction with clear visual cues, a red X for wrong answers, followed by the correct solution. This immediate feedback prevents frustration and turns mistakes into learning opportunities, keeping users engaged rather than discouraged. The results speak for themselves. Duolingo's gamified feedback system has led to a remarkable 40% increase in daily active users, proving that well-designed feedback can transform user behavior. Duolingo's success demonstrates three key principles of effective feedback design: positive reinforcement through streaks and badges, immediate correction that turns errors into learning, and celebration that makes progress feel rewarding. By understanding how Duolingo creates these powerful feedback loops, designers can apply similar principles to make any digital experience more engaging and effective. Imagine stepping into a virtual world where you can hear footsteps approaching from behind, feel the texture of a virtual wall, and see environmental cues that guide your every move. This is the power of feedback in augmented and virtual reality. Three-dimensional audio cues are the foundation of immersive feedback. Unlike traditional stereo sound, spatial audio lets you pinpoint exactly where sounds originate in virtual space. Spatial haptics takes touch feedback into three dimensions. Advanced haptic gloves and controllers can simulate the weight of objects, surface textures, and even resistance when you push against virtual barriers. Environmental visual indicators create contextual awareness in virtual spaces. Lighting changes signal important events, particle effects guide your attention, and color coding provides instant status information. The magic of AR and VR feedback lies in creating seamless interactions between physical and digital worlds. When you reach for a virtual object, your brain receives the same sensory confirmation it would expect from touching something real. Imagine walking into your home and the lights automatically adjust to your preferred brightness, the temperature is perfectly comfortable, and your fitness tracker gently vibrates to remind you about your evening walk. This is ambient computing, technology that seamlessly blends into our environment. Internet of Things devices excel at providing subtle environmental feedback. Unlike traditional computers that demand your attention, IoT devices work quietly in the background, communicating through gentle visual cues, soft sounds, and environmental changes. Smart home systems have evolved to offer predictive status communication. Your thermostat learns your schedule and adjusts temperature before you arrive home. Smart lights gradually dim as bedtime approaches. Security systems provide ambient status indicators that blend into your home's aesthetic. Wearable devices represent the pinnacle of continuous health feedback. Modern fitness trackers and smartwatches monitor your heart rate, sleep patterns, stress levels, and activity throughout the day. They provide gentle nudges and insights without overwhelming you with constant notifications. The beauty of ambient computing feedback lies in its subtlety. Instead of demanding immediate attention like traditional notifications, these systems communicate through environmental changes. A smart speaker might glow softly when listening, or a fitness tracker might provide a gentle vibration when you've been sitting too long. This ambient approach to feedback represents the future of human-computer interaction. By seamlessly integrating into our environment and daily routines, IoT devices create a more natural and less intrusive relationship with technology, enhancing our lives without overwhelming our attention. Modern conversational AI has evolved far beyond simple scripted responses. Today's chatbots use advanced natural language processing to create genuinely human-like interactions that feel natural and engaging. The difference is striking. Traditional AI gave robotic, unhelpful responses that frustrated users. Modern conversational AI understands context, shows empathy, and provides genuinely helpful guidance. Advanced AI systems now analyze each user's communication style, emotional state, and comprehension level. Notice how the same chatbot provides different types of responses. Some users get detailed explanations, while others receive simple confirmations. Emotional intelligence is a game changer. Modern AI detects emotional cues in text and responds appropriately. When users are frustrated, it offers reassurance and patience. When they're excited, it matches their enthusiasm. Real-world applications show this in action. This banking chatbot demonstrates context awareness by remembering the user's name, providing personalized service options, and maintaining conversation flow. It knows when to offer human assistance for complex issues. The impact is measurable. Human-like AI responses build trust by making users feel understood. They improve efficiency by resolving issues faster with fewer back-and-forth exchanges. Most importantly, they create higher user satisfaction by making technology feel approachable rather than intimidating. As natural language processing continues advancing, we're moving toward a future where talking to computers feels as natural as talking to humans. This represents a fundamental shift in how we interact with technology, from commands and clicks to genuine conversation. Imagine a world where your devices don't just respond to your actions, but actually anticipate your needs before you even realize them. This is the future of feedback systems: predictive, proactive, and personalized. Traditional feedback systems are reactive. They wait for you to do something, then respond. But predictive systems use artificial intelligence to learn your patterns and provide feedback before you even ask for it. How does this work? AI systems continuously learn from your behavior patterns, preferences, and context. They build a model of your habits to predict what you'll need next. Contextual awareness is crucial. These systems don't just know what you usually do, they understand when, where, and why you do it. Time of day, location, current activity, and even your stress levels all influence the predictions. Let me show you some real-world examples. Imagine your smart home system that notices you always turn on the coffee maker at 7 a.m. on weekdays. Instead of waiting for you to do it, it starts brewing coffee at 6:55 so it's ready when you wake up. Or consider your navigation app. Instead of waiting for you to open it and search for directions, it notices you usually leave for work at 8:30 and automatically sends a notification about traffic conditions and suggests the best route. The most advanced systems will even personalize the timing and style of feedback based on your individual preferences and cognitive patterns. Some people prefer gentle nudges, others need direct alerts. The AI learns what works best for you. This represents a fundamental shift in human-computer interaction. Instead of us constantly telling computers what we want, they'll increasingly understand our needs and provide helpful feedback proactively. The future of feedback is not just responsive, it's predictive, personal, and intelligent. Imagine you're using a banking app to transfer money. You tap send and nothing happens. No confirmation, no loading indicator, no feedback at all. Your heart rate spikes. Did it work? Should you try again? This uncertainty destroys trust and creates mental stress. Effective feedback loops solve this problem by building trust and reducing cognitive load. Cognitive load is the amount of mental effort your brain uses to process information and make decisions. Trust in technology systems develops through predictable, reliable feedback loops. When systems consistently communicate their status and respond as expected, users develop confidence and feel in control. Good feedback design reduces cognitive load by making systems predictable and easy to understand. Instead of users having to guess what's happening, clear feedback tells them exactly what they need to know. Consider Google Maps navigation. When you're driving, it doesn't just show your route, it provides layered feedback. Visual arrows, voice directions, estimated arrival times, and traffic updates. Each piece reduces mental effort and builds trust. Another example is password strength indicators. Instead of waiting until you submit a form to learn your password is weak, real-time feedback guides you as you type. This reduces frustration and cognitive load while building trust in the system's helpfulness. The relationship between trust and cognitive load is powerful. When users trust a system, they spend less mental energy worrying about whether it will work correctly. When cognitive load is low, users can focus on their goals rather than figuring out how to use the interface. Effective feedback loops create a positive cycle. Clear, timely feedback builds user confidence. Confident users experience less stress and mental fatigue. Lower cognitive load leads to better task performance and higher satisfaction, which further reinforces trust in the system. We've explored how feedback loops form the invisible foundation of every successful human-computer interaction. From the subtle haptic buzz of your smartphone to the complex visual indicators in autonomous vehicles, feedback shapes how we understand and trust technology. Good feedback design solves three critical challenges. First, it builds trust by keeping users informed about what's happening. Second, it reduces cognitive load by making interactions feel natural and predictable. Third, it empowers users by giving them control and understanding of the system. Consider the cognitive burden that poor feedback creates. When interfaces are inconsistent, confusing, or poorly designed, users experience increased mental effort, unfamiliarity, and frustration. This is exactly what good feedback design prevents. Human-computer interaction is a multifaceted discipline that encompasses user research, interaction design, accessibility, and emerging technologies. Understanding feedback is just one piece of this fascinating puzzle that shapes our digital world. The future of human-computer interaction is evolving rapidly. Virtual and augmented reality, artificial intelligence, and ambient computing are creating new opportunities and challenges for feedback design. Staying informed about these developments isn't just helpful, it's essential for anyone working with technology. That's why HCI Explained exists. Every week, we dive deep into the principles, practices, and emerging trends that shape how humans and computers interact. From fundamental concepts like feedback loops to cutting edge developments in AI and immersive technologies. Subscribe to join our community of designers, developers, researchers, and technology enthusiasts. Together, we'll explore how thoughtful design creates better experiences for everyone. Because understanding human computer interaction isn't just about building better interfaces, it's about building a better digital future.